I'd like to thank Peter for giving us a talk on logo. There is a second part 2 to this talk, and it's going to be on Friday afternoon, and that's going to go more into turtle robots, which I'm sure Peter will mention today. So don't miss that. Thanks, Peter.
Thanks, Andy. How many people have heard of logo? Just about, well, I think everybody's heard of logo. And a lot of the people I've talked to think of logo as a child's toy, a game. And I'd like to spend part of this presentation showing why it's a serious programming language and a serious educational tool. There's more to it than just turtle graphics, which is what most people think of when they think of logo. And then I'd like to spend about the last half of the presentation with a tutorial, give you enough about logo to get started to go off and start writing some of your own logo programs and exploring it. Logo is an educational philosophy. It's a way of teaching. Logo is not just the programming language. Logo has roots in artificial intelligence, mathematical logic, developmental psychology. The ideas behind logo started back in the mid-60s. Logo was created at a private research firm on the East Coast, BBN, which has done a number of other things in computing. And it was designed based on constructivist learning theory, a theory about how children learn specifically, the theory that there's a lot of learning that can be had by interactive exploration rather than structured curriculum. And this is pretty revolutionary in the education system at the time, and to an extent even today. The earliest creators of logo imagined a revolution in the education system for teaching mathematics, and years later there were factions within the logo community, some folks who wanted that revolution to completely replace the current system of education for mathematics, and the other group of people who saw it as more realistic to work some of the ideas of logo into the existing education system. The first version of the logo in 1966 ran on a PDP computer. They had no graphics, they had no robot, they had no turtle graphics. I think logo is best known for the turtle, which we'll see later. I'll show you how that works, but that concept didn't exist at that time. Then, late 60s, 1969, we had small robots called turtle robots that were attached to the computer and would move around in response to commands typed within logos such as forward or back or left or right. Those turtle robots also had small pens attached to them, so they could draw patterns on them on typically a piece of butcher paper. Later, 1970, logo development moved to the Massachusetts Institute of Technology in Massachusetts. Other schools and research institutes around the world picked up logo. There was quite a bit of interest in logo in both Edinburgh and Tasmania. I don't know why those particular areas picked up logo, but if you're reading a lot of the older logo papers, you'll see quite a bit coming from those areas. Early 70s, we got turtle graphics. By this time, graphical terminals became affordable, where affordable meant a whole another PDP computer just to do graphical processing. The graphics, in contrast to the small robots, were called screen turtles. So we had screen turtles, which were a on-screen simulation of the floor turtles, the physical robots. And tomorrow I'll talk a bit more about the robots, the history, where the name turtle came from, and show some pictures of that. By the late 70s, we had the personal computer, and there was a new possibility for logo in the education system. One of the early problems with logo is that it was difficult to get it into a school. It was expensive to get it in there, and even if you put your expensive time-sharing system in there, it in one room. You couldn't get your entire classroom in front of it. The design behind Logo was looking to teach specifically mathematics to grade school children. In 1980, a fellow by the name of Seymour Papert, who was involved in the earliest development of Logo, published a book titled Mindstorms. Here's one copy. This is a reprint from the early 90s. And this book got the attention of a lot of school teachers. This book was eye-opening and motivational for a lot of school teachers, and following that, a lot of schools adopted Logo in various forms. My first introduction to Logo and both the Apple II was in 3rd grade when we had a lab of Apple IIes with Logo, Apple Logo actually. There are over 248 versions of Logo, probably more. Actually, there's at least 249, but that count does not include a ByteWorks 3D logo. Logo is unique in that the development of Logo was fragmented across a lot of groups. Their research started at a private institution, and it moved to MIT, and then, as I mentioned earlier, some other universities in Edinburgh and Tasmania picked up Logo research. There were schools doing Logo research. There were several private companies developing Logo as well, and just here I have 3 different versions of Logo for the Apple II, and there are more. So I'd like to highlight a couple of the versions of Logo for the Apple II. Again, there are more, and probably ones I've never heard of. Just the other day, Stavros showed me a couple of the Logo Toolkit and Logo sample programs that I'd never seen before. Terrapin Logo is one of the earliest versions of Logo for the Apple II. This is the version from 1980. Terrapin was developed by a company called Terrapin. Terrapin actually licensed Logo from MIT, and you'll see the MIT copyright all over the manual, and when you start the software up, you also see that. There was a DOS 3.3 version of Terrapin. That's what I have here, and Terrapin gradually improved Logo over the years. There were at least, I believe, 6 different versions of Logo, culminating with Logo Plus, which was ProDOS based. Right side, you see an ad for Terrapin Logo. Obviously can't read it there, but it highlights a lot of the features I've been talking about. I can't even read it on here, but I'll show you this Logo program later, actually. This is Apple Logo. Is probably the most popular version of Logo for the Apple II. Apple did not actually write Apple Logo. They licensed it from a company called Logo Computer Systems International. They're in Canada. The history of LCSI is interesting because they did not use MIT Logo. A number of folks working at MIT spun off this company, LCSI. They didn't want to deal with the MIT copyright, so they rewrote Logo. LCSI later released Apple Logo 2, Apple later released Apple Logo 2, which was again licensed from LCSI. And this ad was from, I believe, 1982 Nibble magazine, and I like the title here. It's time kids started using strong language. It's catchy, but it's also saying something serious about Logo. It's pointing out that Logo is more than just a toy. It's a much more sophisticated language than something like BASIC, and we'll see that later. It's designed to be interactive, to explore, to make mistakes, to try again, to teach Logo how to do something new. These are some screenshots from Apple Logo 2, which I mentioned earlier, licensed from LCSI. I also have LCSI Logo 2 here. I'm not entirely sure how it differs from Apple Logo 2. Keep in mind, though, that this is the company that licensed Logo to Apple, and I'm looking. Yes, LCSI rewrote Logo because they didn't want to deal with MIT copyright. But interestingly, there were a lot of folks from MIT involved with the MIT development of Logo that later joined LCSI. If I'm not mistaken, the fellow who wrote this book, Seymour Papert, was part of Logo. Sorry, part of LCSI, and founded that company. And I just talked about LCSI Logo. I was also a logo writer. I don't have much personal experience with this. I've talked to enough people that I know it was popular, and articles I read indicate that it was a significant step forward in logo. It was more of a word processing type environment than earlier versions of Logo. And we see some examples of screenshots here, and it doesn't show it in here, but there's the idea of sort of tabs, different word processing documents, if you will, with the logo in it that are actually automatically saved. There are many other versions of Logo. I will show you Byteworks 3D Logo in a minute, so I won't talk about that. Byteworks Hyper Logo is a version of 3D Logo to work with as an embedded scripting language in another Byteworks product. Krell Logo. Krell is out of business. I don't know much about Krell. I haven't been able to find the software. Terrapin and LCSI, in contrast, are still in business today, and they are still selling Logo for the Mac and the PC. LCSI also released a number of other Logo products. They had Logo Writer for the Apple II, the 8-bit. They had a product called Logo Ensemble. It's supposed to integrate spreadsheets, databases, word processing into Logo. I don't quite know how it does that. In the copy of the slides that'll be up on the KansasFest website later, there's some links to some of these versions of Logo. There's LCSI actually had a long list of products supporting their Logo. Lego released a version of Logo called Lego TC Logo that, with the right interface card, would allow you to interact with Lego pieces, build your own Lego robots and so on, and then use that. It is the successor. For the Apple II, it was first called Lego TC Logo, and then there was, I think, Lego Control Lab, and then we got Lego Mindstorms, which is what we can get today. Mech Easy Logo, I believe that is based on top of Apple Logo, and it's designed for younger children. It's more of a graphical, pick things from a list. Yes?
There's a freeware logo available for Mac OS 10, by the way.
Okay, got it.
You guys the link when you're done.
Okay, thank you. There's another version of Logo called TeleTurtle. I can't find out much about it. It doesn't look to be a complete version of Logo, more of a turtle graphics for young children without all the things that make the logo interesting. Maybe I'm wrong. I haven't experimented with it that much, but because Logo is best known for turtle graphics, there were a number of products that took just the turtle graphics and gave you just that, which is a start, but it's not really what makes Logo interesting. There was a version of just turtle graphics published in Nibble early 80s as well. Two versions, okay.
There was one in 1982, and one in, I think, 1986, if I'm not mistaken.
Oh, okay. Good to know, thank you.
But those just do turtle graphics.
Yeah. As I said, it's interesting, but I think without all the other things that make Logo, it gets pretty boring pretty quick. There are a lot of other companies that release books, curriculum, add-on packages, so on for Logo. Just thumb through the pages of your favorite magazines and look at the ads, look at the software listings. Any questions so far? So I'd like to switch over to Byteworks 3D Logo, and we'll actually do some things with Logo. I chose Byteworks 3D Logo because it's the only one that you can readily get today. It's still commercially available from Syndicom. Whatever version of Logo you get, you want the manual with it. There's enough variations between the versions of Logo that if you have the wrong manual, you'll probably sit there frustrated. Yes, Byteworks 3D Logo runs on a 2GS, GSOS. Byteworks 3D Logo came relatively late in the life cycle of the Apple II. I don't believe it was used very widely, but it's still a good version of logo with some interesting features, such as the 3D features, which we may or may not have time to look at today, and some ability to write desktop programs on GSOS, and what else is in there? Abilities to make movies and things like that. Okay, so this is the interface for logo. On the left-hand side, we have the triangle, which is the visual representation of the turtle, the screen turtle. On the right-hand side, we have the opportunity to type commands in.
Can you define briefly in a couple of sentences what a turtle is?
Yes, a turtle is an object to think with, and that's using the term from Seymour Papert. It is a tool for interacting with the computer, relating with the computer. Imagine, I mentioned earlier the floor turtles, the small turtle robots that connect up with logo. And then later that moved into an on-screen simulation. And in both cases, the turtle was there as a tool that allows the child, the student, to relate with the computer. A turtle is something that a child can imagine they are. They can imagine that they are the turtle. They can imagine that they're doing the commands. They're walking forward, back, turning right and left. It helps them relate with the computer. It helps them relate with the mathematics. So we can give the turtle commands. Let's give it a simple command, forward, or abbreviated FD, and then the number of steps. In this version of the logo, the number of steps is the number of pixels. So let's go for 30. And the turtle moves 30 steps forward, and it happens to draw a line. Imagine a real turtle with a pen taped to it, walking 30 steps forward. A lot of the curriculum for elementary school children focused on imagining that you're the turtle. A turtle has a very clear front, a very clear direction of walking, and it was easy for the children to relate to it. Again, the turtle graphics aren't the point of logo. It's an object to think with to help you interact with the computer. The goal here was to create an interactive environment to explore, to understand mathematics. And you'll see the phrase mathland in some places. And that's the idea of a virtual environment for exploring math. The turtle can also take commands to turn, such as right turn 45 degrees. We can make the turtle go backwards. Let's make him go backwards 60 steps. And we can also change the color. You set pen color. And I don't remember which number corresponds to which color, so we'll go with color 6. And I'm going to make the turtle now go forward 70 steps. And we happen to get an orangish color. We can also raise the pen up so we can move the turtle without drawing a line. To do that, we use the command pen up, or just PU. And let's rotate the turtle again. Let's move him forward a bit. No line. The opposite of that is pen down, or PD, 90. Oh, sorry, not 90. A pen down, and then let's do forward 60. And we can change the color again. PU is one of my favorite commands in 3rd grade.
Yeah.
for obvious reasons. Yes.
Actually, a lot of these abbreviated commands you can actually type out as full words.
Mm-hmm.
You can actually, I think, type pen up and pen down instead of PU and PD.
Yep, I can type right. I can type forward. And I can type right again. My turtle went off the edge. There he is. I can also type home, which moves him back to the center. And do left. And we can do back. So it's just back. Yeah. So we can type out the full words if we prefer. That probably would have been clearer for me to demonstrate, but either works. Yes.
So I'm familiar with some of the graphical elements of the logo.
Yeah.
But you're mentioning some of the advanced features or functionality of logo. Can you give me an example of what some of that is?
Yes, I can. Let's start off with the procedure. Imagine that you're working in this mode, you're entering commands, it's immediately responding to you. Now you figured some things out. Let's say you figured out how to draw a square. The next step in the sophistication of logo is that you can extend logo. You can teach it how to draw a square. So let's go ahead and do that. We can tell logo, okay, to draw a square, you need to, well, draw 4 sides. Maybe you didn't know that at first. Maybe you experimented and figured that out. And they're going to make each side, let's say, 30 pixels long. So move forward 30, right turn 90, and then end. Now I've just taught logo how to draw a square. I'm going to clear the screen, CS, and now I type square. It's very simple, but take a look at what I just did. I taught logo how to do something new, in this case just draw a square. I was able to give it a name that makes sense to me. I call it square. I can call it anything I wanted to. Compare that with, say, basic, where you maybe give it a line number, and you hopefully remember that, and it has no meaning to you. Logo treats square as if it was built in, so I can then define other procedures that build on top of that. Maybe I just started with a square, but what if I also define a triangle, and then I put a triangle on top of my square, and then I define a new procedure called house, and then I take my triangle and create a new procedure called tree, and then I combine several trees in a house and I make a procedure called forest. And then let's say I create a procedure called dog, and then I create another procedure that animates the dog. And you can see how I can build incrementally up on top of things. And I can start with simple pieces, I can move to more complicated pieces.
Can you do things like circles or ellipses?
You can, yes. I don't remember the command for that. I think it might be arc.
Actually, you can,
Nope.
no, try, third screen. The simplest one is repeat 360,
Yeah, I see what you're saying.
FD1, RT1. That will take a while, but it will draw a circle. And then if you do, I think, repeat 36, FD10, RT10, that'll also give you, it'll,
Size 1, that circle's kind of hard to see.
Yeah.
Well, no, but in Apple logo, it would actually draw a full circle. So I'm surprised it's doing it that small.
Yeah, I know what you mean. This is a common way of
Make
drawing a
forward
circle.
about
Here,
10.
do repeat 36, FD10, RT10. That might
There
be
are
a better circle.
some versions of logo also have a built-in command for drawing circles and arcs.
Right.
I don't remember if...
Apple logo.
There we go. Also take a look at the square procedure I defined here, and also the examples that Stavros just gave for drawing a circle. We can use loops. There's other types of loops. We can use if, then, else statements. Fairly sophisticated concepts that we just don't get in basic. It's a lot easier to express what you want to do using logo, partly because you get a richer set of commands that are built in, and partly because you can use names, you can create procedures, you can create things like local variables and parameters. So let's take square one step further. My square procedure draws a square. It does a great job of it, but it only draws squares with a side of 30. Logo gives us the idea of a parameter, which allows us to create a variable within our procedure that we can give a value every time we run it. So let's create another square. I'm going to call it square v for a variable. And now I'm going to tell logo that a square needs to know the length of a side before it can run this procedure. and it tells me it needs to know something. So I can now draw a square of side, let's say 20. There we go. I just generalized my knowledge. I figured out how to draw a square, and I generalized that. I figured out how to draw a square with different sides. I can then build on top of that. I can create, let's say, another procedure called boxes. Maybe it draws, let's say it draws 10 squares. Oh, let's go for 50. So I just built on top of that. To write boxes, I don't need to know how square works. Oh, that's not really what I wanted. I would rather not draw all the boxes on top of each other. So, no problem. I can edit my boxes. And let's do a left turn. Let's go for 20 degrees. Pretty simple. We started to create more interesting graphics. And we don't have to stop there. We can, a procedure can also call itself. Remember when I create one of these procedures, it's as good as it's as if I am extending the Logo language. It's as if I'm adding something to Logo. So I can create, let's say, I'm going to create a procedure called PolySpy, which is an example that shows up in a lot of the Logo books and manuals. And it stands for polygon spiral. It's extending the idea of a square into a spiral, and it also shows how you can have a procedure that calls itself. Yes. And that is not what I wanted. PolySpy is going to take two parameters. It's going to be side and angle. And then let's go forward side, right angle, and now I can call the procedure. I'm going to side +1 and an angle. Any idea what that's going to do? It's really similar to what I did with square, but different, and I have this weird thing where I'm calling myself with the longer side.
Actually, why don't you do side +10? It'll get a greater gap between them.
Yeah, let me try this. I had a couple of parameters that seem to work well. If that doesn't work, then I'll change it to 10. Well, that went off the screen. I did the step too large. What just happened there? Pardon? Yeah, exactly. So it keeps calling itself. It's called recursion, as Stavros mentioned. And PolySpy calls PolySpy, which calls PolySpy until the computer just runs out of memory and has no idea what to do. And that's what it means by stack space. Let's see if I...
When you do the first mention of PolySpy, up there you do PolySpy and then N. That just wipe out the code.
No, you define PolySpy.
Yeah, but that defines PolySpy, but you didn't have a formula and you just entered the N.
You forgot to
Yeah.
put in the parameters, so he ended it and created an end.
Okay,
Mhm.
so then
Exactly. There we go.
There you go.
Yeah, exactly. I made a mistake the first time, no problem. Logo lets me go ahead and define it again.
PolySpy 290.
Thank you. There we go. I keep running out of stack space. So the next step with recursion is figuring out when do we want to stop. And let's go ahead and do that. One thing I noticed about ByteWorks logo is that it runs out of stack space a lot sooner than even some of the 8-bit logos. And notice I'm using some different symbols here. When I'm talking about the value of a variable, I use the colon. If I want to talk about the variable itself, not the value, just the variable or a procedure with that name, I'll leave the colon off. If I want to talk about, they call a word, a name, then I put the quote in front of it. So in this case, if I type edit PolySpy, it would go ahead and try to run PolySpy, and then call edit, and it doesn't work. PolySpy wants parameters, which I didn't give it, and then edit wants parameters, which PolySpy didn't provide, because it's not designed to do that. But if I put the colon there, it says pass the name PolySpy into edit. So we wanted to end. Any idea how we can stop my recursion? A loop counter, yes. We can create local variables in Logo, which is a concept that is not found in BASIC, but is found in most other languages. So we could create a variable using make. For simplicity, I'm just going to say if side gets too large, let's say side gets larger than 30, then stop. This is one area where the different versions of Logo are quite a bit different. Some will require you to put some will require you to put a then in there. Some will require you to put the brackets in there. Some will require you to not put the brackets in there. All right, tells me PolySpy created. My new PolySpy. And let's just go for a different color. And we found that PolySpy 290 worked well. Let's just do 285 or something different. And it's also in red, so you can't really see it. ByteWorks logo also supports the 320 graphics mode, and the colors look a lot better in there. I'm using the 640 mode because I didn't want the text to wrap as much for the demo. It's harder to read that way. So there's my new shape. Notice I didn't run out of stack space. Questions? Things you want to see? Yes.
How do you access it? You said this was 3D. How do you access 3D functionality?
Okay. There is a separate set of commands to rotate the turtle out of the page or into the page. It's RO for rotate out and RI for rotate in. There is an example that comes with ByteWorks 3D logo. I'll show you that. Let's do cubes. Oh, I didn't do that right. There we go. Cubes created. When I'm doing 3D, I want to use the command CS3D, clear screen 3D. I also want to be in 320 mode for the colors to work out right. So let's go ahead and switch that. Okay, CS3D, and then cubes.
Oh, that's if you have 3D glasses.
Yes, if you have the red and blue glasses, this will be in 3D. If I just had the regular 3D, it would draw it as wireframe for if you didn't have the glasses. It's a unique feature. Say again? I know I should have. Does anybody have one?
Yeah.
Well, there's a homework project for you. Anything else you'd like to see? Yes.
If you redefine a procedure that some other procedures are using, do you change the one they're using, or they still use the old one?
They will use the new one. So if I create my square procedure, then I create something else that uses square. Let's say I create a house that uses square. I can go and change square, and my house will start using the new square. So we could actually give that a try if you want. So I think I still have my square procedure. And let's go ahead and make a house procedure. Yeah, we're going to draw a square. And then, actually that's not what I want to do. Let's do this again. House, I'm going to use a square V, the one with the variable side. I'm going to make a square size 40. And then I'm going to move, actually, why doesn't someone else write this for me? What should I do now? Okay. Now what? Okay. So I'm going to draw a triangle, right? So let's just type triangle in. And triangle is not defined. Oh, it tells me. I don't know how to do a triangle. So let's go ahead and tell it how to do a triangle. Comments? How should I do this? Right, 45. Yeah. We can do math in here too.
Can you use sine, cosine, not like geometric, trigonometric functions?
We do, yes.
Oh, you're gonna have a problem
You
there.
don't need to use those with this.
40 divided by the square root of
You
2.
didn't define the size of the triangle.
No, I didn't.
Yeah.
Just make it with the point off to one
Oh,
side
yeah,
and
and
a slanty. Make it a right triangle.
Okay.
Just make it a right triangle that way.
40 times the square root. Yeah.
Okay, let's start over.
30, 60, 90.
Okay, that's a good idea. So I'll make it a weird looking triangle. We'll go forward. Let's go forward. Forward 40, let's turn right 90, forward 40, and then what's the last angle going to be?
Wait, if you're doing a right there, it's a 3, 4, 5. It should be. It should be forward 30. Let's see, 3, 4, 5.
Yeah, but he's adding to his house, so he's already starting
Oh,
at
okay.
45 degree
Yeah,
angle.
the problem is you've gone 40 and you're gonna cross 40.
Mhm.
Now if you go 45, you're gonna come back here and you're gonna have like a
Well,
high
you go
dimension.
up,
Go forward 40, right 120.
Yeah.
Forward 40,
Right 45.
right 45.
no,
120.
you're already at a 45 degree angle. You gotta go 90.
Well, let's focus on just drawing the triangle.
Oh, just.
Yeah, let's just draw the triangle. We don't have to worry about the house, and then we'll combine it in with the house later. So triangle.
Right 45, right 45.
45 is the only thing we can agree on.
But we still need to do the forward 40 to the top of the house.
Let's just get right
Yeah.
Do that in the house.
Is this a 45, 45, 90 degree right angle?
How about 60, 60, 60?
60. Okay, 60, 60, 60. So let's go forward 40, and then right 60, and forward 40, and right 60.
Straight up 40 is the best.
Yeah.
Now,
We can put in
you
a
want
angle change
to
to begin with. We can change the orientation of the drawing.
No,
You want
that's
right
okay.
120.
okay. So forward 40, right 120, forward 40, right 120, and then another forward 40. I did.
You went right 20.
Yep.
You do it, repeat the same thing 3 times.
Yes, that would be even easier. But this is part of the point of logo. You can explore, you experiment, you get it wrong. You have You have the turtle graphics to help you visualize what's going on, what might be going wrong, and
Any computer programming would take, you run a light bulb. Not a hardware problem.
okay, maybe this has a chance to work. Oh, beautiful. Okay. So, uh-oh. But again, we can fix that. So we're going to want to go, let's see, right 30. There you go. The roof's a little small, but no, the roof's a little small.
It's not good there.
And Logo does give us a full set of mathematical functions. We've got cosine, sine. We've got random numbers, ovals, rectangles. We should have a square root in here somewhere. Yeah, we do have square root in here. Probably could have used that. It is.
Weren't we gonna do something with this house? Was the whole idea after we got the hospital?
We're gonna sell it for $300,000.
So your original question is, if you change something that's referenced elsewhere, does the existing procedures you defined reuse that? And you just saw me change triangle, and it was referenced in house. So the long answer is yes. Everything is referenced by name, so you can change things, build things up. You can then go back and change some of the little details. And maybe I go ahead and build a whole village out of this house. Then I realize, oh, I messed my triangle up. I couldn't figure out my Pythagorean theorem. I can go back and fix triangle later. But it's close enough to start with. Anything else you'd like to say? See? Questions? Yes?
Technically, you have to redraw the bottom line of the triangle, or can you just draw those two lines? If you're building a house, you don't need to redraw that horizontal line.
No, you don't. It was easier because I could separately define the square and the triangle and stick them together, but you don't need that.
You might want to use triangle someplace else.
Exactly. If I had a triangle without a bottom, and then later on I said, oh, I want to draw a tree. I have this triangle. Great. Make it green. It looks like a tree. But it's missing a bottom. I just frustrate myself. Other questions?
You have to call it roof.
Yeah, there you go.
Is this saved?
Say again?
Is it saved in any way? Is it automatically saved? Do we have to go out of our way to save that environment?
It does not automatically save in ByteWorks Logo. Some versions of Logo do, specifically Logo Writer. Most do not, but there is a save right here.
Do you have a fill command?
Yes, we do. It
So you
is.
could fill the square with yellow or something like that. Could you?
It's a flood fill, so we have to put the turtle. So I'm going to do pen up so I don't draw any lines.
Much work it would take to build that with a 3D representation on a flat surface, you know. In other words, like a mechanical drawing, so that it would go back to the,
With the ByteWorks Logo, not too hard because it has built-in commands for 3D. So you can draw wireframe 3D graphics with ByteWorks Logo without having to try very hard. This book has several chapters about three-dimensional graphics. This is a book from the early 80s, contemporary with Terrapin Logo. It's one of the more intellectual books that goes along with Logo, and it talks about three-dimensional graphics, different relationships between turtle geometry, the stuff you see on the screen, and what I'll call real mathematics. What is that book called? It's called Turtle Geometry, The Computer as a Medium for Exploring Mathematics by Abelson and DeSessa.
ABELSON.
P-I-S-E-S-S-A. I'll have this book up here afterwards if you want to come look at it. And you had the question about the filling. The answer is yes.
Ah, okay.
There you go. Greenhouse. Am I about out of time? Okay. And the presentation there's another slide in there. It has a few more links to things you can follow to learn more about Logo. The notes at the bottoms of all my slides have some useful references. And there's also another book, Computer Science Logo Style. It is an undergraduate computer science curriculum using Logo. This fellow also has a version of Logo for the Mac and PC called UCD Logo. And the book itself is free, 3 volumes off his website. It's a PDF. And the Mindstorms is an excellent book. It doesn't go into technical details, but it gives you the concepts and ideas behind Logo.
So there's that other one that I mentioned before called ACS Logo for Mac OS 10.
Mm-hmm. There's 200 or 300 versions of Logo, and there's a number of free versions available for your favorite operating system. There's a version for the iPad. I have not tried it. Yeah, Ken mentioned it in Open Apple a month or two ago. The Logo for the iPad. Remember the name of that?
Yeah, it's in the show notes.
Okay, show notes.
Was that in the episode you were on?
No, it was one after that. I think 3 or 4. Oh. Nope. Maybe the speakers aren't turned on.
Logo Draw for iOS.
Yes, I haven't tried that one. Oh well. Anyways, Byteworks 3D Logo also has speech synthesis built in, which is kind of neat. All right, thank you. I'll have these books and copies of Logo up here later if you want to look at it, and I'll also have it up in my room.